So this is the binary tree. I know you are familiar with the concept of binary tree because you have discussed this in some of your courses when you were in first year or even in mathematics course. So there are three nodes or components of a binary tree, namely the data, pointer to the left child, and pointer to the right child. So we have the following terminologies related to a binary tree. Have node, the most elementary unit of a binary tree, because we call every like for example this one, every circle that corresponds a given data 1, 2, 3, 4, 5, 6, 7 up to 13 or 14 or whatever data being given, we refer it to as a node. Then the root would be the topmost. So on the given tree a while ago, 1, the root, because that is the topmost element. There is only one root in a binary tree. Then you have the leaf. The leaves of a binary tree are the nodes, which have no children. So there are also different levels, or there are levels also, which represents the generation of a respective node. So level 1, level 2, level 3. If it is level 0, the root has level 0. Then the children of the root node is at level 1. And the grandchildren of the root node is level 2 and so on. So going back to the tree, so we have level 0, 1, level 2, 2 and 3. Level 3 would be the grandchildren of level 1. And then we call it also the parent node or the parent. The parent of a node is the node that is one level upward of the node. So like for example, 2 and 3, one level upward. So the parent of 2 and 3 would be 1 since this is the root. For the parent node of 4 and 5 is 2 and so on. So that's how it is represented. The terminologies are being represented in a given binary tree. The children of a node are the nodes that are one level downward of the node. So going back again, one level downward, so ito yung mga children or child, C2, C4, and 5. Children, D2, C4, and 5. So this is how it is being implemented in Python, or the algorithm of implementing a binary tree using Python. So we have to define our class node. Then after defining the structure of our class node, we're going to initialize the attributes of the node. So what are those attributes of the node? We're going to define them. So we have def init, because we're going to initialize the attributes, self, and then data. So if you're going to represent or initialize an attribute of a left child, so you have to represent it as self dot less equals none. So that would be the left child. Then self dot right equals none. That would be the right child. And self dot data represents the data. There's no node. So this is once again to define the node class. We initialize our tree. For you to visualize what you have initialized on its attribute, you can represent it also this way. Lagay nyo lang sa remarks. So, self.left none, self.right none, self.data. Then we're going to initialize the value of root, which is 10. And then if you want to initialize the value of left root, so we do it this way. Root.left equals node 34. This is setting the left child of the root to 34. Then root.right is equal to 19, setting the right child of the root to 19. So in the tree structure, you have 10, left node would be 34, then the right node would be 19. So 3 represents the nodes connected by edges. It is a nonlinear data structure. It has the following properties. One node is marked as root, just like what I have said a while ago. Every node other than the root is associated with one parent node, and its nodes have an arbitrary number of a child node. So we create a tree structure in Python by using the concept node that we have discussed the following. So this is how to create. Similar, just like what I have presented a while ago. That's how to create class node or a tree in Python. This is an example. So what would be printed here? It will simply print the value of 10 as the root. Okay? So how to insert? To insert a tree into a tree, we use the same node class created above and add an insert class to it. So the insert class compares the value of the node to the parent node and decides to add it as a left node or a right node. Then finally, we have to print the tree. Class is used to print the tree. So that's how to insert. Now traversing naman. How do we traverse a tree using recursion? As you notice, 1, 2, 3, 4, 5. So what is traverse? Anyone who would like to read the definition of traverse as presented above? I call on Hans to read the definition of traverse.
What is tree traversal? Traversal is the process of traversing the node of the data structure. But if you use the data structure like the stack, queue, or linked list, then it becomes difficult for traversing the nodes because this data structure is linear and hence the time complexity of traversal increases.
Okay, so this is the application of what you have discussed last time, yung sa expression natin. Cost infix, prefix, and postfix. So sa traversal naman, we have in-order traversal, pre-order traversal, and post-order traversal. So you look at the arrangement of the different methods of traversal in Python using recursion. So in order, you have left, root, right. You have to follow the order. Left, root, right. So nasa gitna yung root. Then sa pre-order, mauna yung root, and then left and right. So sa post-order traversal, left, right, root. So you have to remember strictly this concept of the three methods of traversal using Python, okay? With recursion. So this is an application of in-order traversal. First, calling in order left subtree. Visit the root node, then calling in order right subtree. So this is how in order is being used. Nasa gitna yung root, and then left, right. So for uh, okay, one moment.
Ma'am,
Yes,
wala
any
daw
question?
kina Div Iverson Santiago, ma'am.
Bakit? Walang?
Kuryente, ma'am.
Okay. So I have here, you'll work as a group. Construct a binary search tree for the following given data: 80, 40, 75, 30, 20, 90, and 50. So apply the concept of binary tree. Then you're going to construct a binary search tree on the following data. Okay, I will group the team. Ilang kayong lahat? Kate ngayon? 30. So I'll group it to 6 groups. Then discuss among your group mates and give you 1 hour to do this one. And then you're going to present your output after 1 hour. Okay? I'm now creating the team. Then I will open now the team for your group discussion. Okay, you can close your camera meantime to save your data while you are working with your group mates.
Ano?
Dalawa.
Order ka na.
Oo, dalawa. Nagdailan niya kan. Sa kanila, dalawa? Sirado, ah? Ay, gutan mo na, abutan mo. Katoka mo.